The year 2024 has become the hottest year on record. The heating of the planet reached an unprecedented level, with millions of people being affected by natural disasters, and climate change only continues to aggravate.
The causes of anthropogenic climate change have been identified for a very long time. We know it all very well.
Many steps have been taken already to combat global climate change. For example, many countries are striving to reduce the amount of carbon dioxide and other greenhouse gases that they emit into the atmosphere. Clean energy technologies such as solar and wind power, they're being implemented. And projects aimed at restoring deforested areas and protecting forest ecosystems, they're also being developed.
Since 1992, we have made significant progress in international agreements to reduce greenhouse gas emissions into the atmosphere. However, catastrophic events continue to escalate at an alarming rate.
Someone might say that the efforts made are not enough. The fight against climate change has been going on for more than 30 years. But what if there's something we haven't taken into account? What if we still don't know enough about our planet and how much we're affecting the climate system? Let's think about that.
NASA's chief climatologist Gavin Schmidt expressed his concern about record-high temperatures in 2023. He said that the temperatures not only broke the previous records, but also showed that there are some unknown factors causing heating that exceeds the usual long-term trends of the previous models. In other words, there are other factors of the planet's heating that we haven't yet taken into account.
Leading renowned scientists are telling us that additional factor X has now emerged that is heating the planet. Let's talk about it. Perhaps it is not so unfamiliar to us. There are several key elements in Earth's heating system. There's the sun, there's the surface that gets heated, and there's the atmosphere with its greenhouse gases. We're familiar with greenhouse gases. The sun, as the source of heat, is stable and constantly sends the same amount of heat to Earth. Depending on the season, some parts of the planet receive more, some less. We already know how the atmosphere affects heat. Then perhaps an additional factor in the Earth's heating is hidden in an element of the Earth's surface. And what makes up most of the Earth's surface?
The world ocean covers nearly 71% of the Earth's surface and contains more than 97% of the planet's water.
The ocean is amazing. It is our lifeblood. It provides us with oxygen and is home to millions of species of living organisms.
The world's ocean is not only a cradle of life, but also a climate regulator. For centuries, it has been keeping our planet in balance by regulating the temperatures in the atmosphere. But today, the ocean, it really needs our protection. Otherwise, we risk of losing everything.
What if significant changes have occurred not only in the atmosphere, where we've added greenhouse gases, but also in the ocean, which is essentially the largest surface heated by the sun?
The ocean absorbs and stores a huge amount of heat coming from the sun. Water heats up slowly and can retain heat longer than air does. This helps mitigate fluctuations in temperatures on Earth.
Basically, it's the Earth's thermostat. Let's run a diagnostic on it.
In 2023, the absolute record for ocean surface temperatures in the entire history of observations was broken. The year 2024 already exceeds all records of 2023.
According to the data from an international group of scientists, as of 2020, the ocean is starting to warm 450% faster than previously over the past 30 years. And this is truly shocking. The scientists have calculated that to heat the ocean at such an alarming rate, it would require the same amount of energy as detonating 7 atomic bombs, like those dropped in Hiroshima, every second for an entire year. I mean, can you imagine such an enormous amount of energy? And that begs the question, where did all this energy come from?
Scientists have managed to measure the heating of the Earth's surface, and this heating is accounted for in the climate models we know. However, the ocean's surface makes up only about 0.1% of the total volume of water in the world's oceans. Could it be that factor X, the one heating the Earth, is hidden in the remaining 99.9% of the ocean? In that case, we have two options. The first option, let's assume that more heat started flowing into the ocean from somewhere. For now, we won't raise the question where it's coming from. The second option, something has changed the properties of the ocean and it has started to accumulate heat more than before, meaning it has stopped releasing it. To put it figuratively, the ocean used to be like a glass of boiling water. It was giving off heat to the atmosphere. But what if now the ocean isn't acting like a regular glass of boiling water, but more like a thermos with soup, not giving off heat as willingly as it used to? Think about it. We added something to the ocean water that made it a soup.
The world's oceans have never been so heavily polluted before. Up to 30 million tons of oil get into the oceans every year due to oil production and transportation, tanker accidents, river and industrial runoff.
The pollution of the world's oceans with oil and petroleum products is only half of the problem. An even greater threat comes from what we have learned to make from oil, and we're talking about those very plastics. Today, the total area of these plastic islands of garbage on the ocean surface is almost the size of the United States and Australia combined. Let me say it again. The area of the US and Australia combined. That is how much we have polluted the oceans.
Researchers estimate that currently there are between 75 and 199 million tons of plastic waste in the oceans, with 15 million tons of plastics getting into the marine environment annually. This is comparable to 6,700 Olympic-sized swimming pools filled with plastics and entering the ocean every year.
And do you know what actually happens to plastic when it ends up in the ocean? Under the influence of sunlight, salty water, waves, and wind, large plastic debris breaks down into smaller particles. Plastic can break down into particles just a few millimeters in size, and at that point, we call it microplastic. These particles are visible to the naked eye. But let's continue with the process of plastic breakdown. What happens next? When plastic particles become smaller than 1 micrometer, they turn into nanoplastics. These particles can only be seen under a microscope. The key thing here is that plastic never fully decomposes. It doesn't undergo biological degradation like organic matter. You see, it will never decompose on its own. Never.
Nanoplastics represent the final stage of plastic waste destruction in the ocean. These tiny particles retain the polymer structure of the original plastic, but because of their small size, they have new properties. For instance, they easily penetrate into the tissues of living organisms. They can overcome biological barriers, easily enter food chains of marine ecosystems, and can accumulate in the tissues of living organisms.
The areas with high concentrations of plastic waste are called plastic soup. This is exactly that soup we were talking about earlier. In the past, our thermos contained pure seawater, but now it's filled with plastic soup. And here arises the question, how has the addition of nanoplastics affected the thermal properties of the water? Let's take a look at the graphs, showing the amount of plastic produced since 1950 by different types, the total amount of macroplastics in the ocean, and changes in the temperature of the world's oceans. Look, they all grow in sync, in geometric progression. Doesn't this suggest that plastic in the ocean has significantly affected the ocean's ability to retain heat?
Due to its specific composition, microplastics have a unique property. They disrupt the ocean's heat conductivity. So, the cause of a disruption of the ocean's function is the anthropogenic factor, and more specifically, it is the plastic that we have created, and now it is everywhere in the ocean. And instead of removing heat, the ocean has become like a thick blanket for our planet. And the planet is exactly what needs to be cooled.
So while the way nanoplastics can affect the thermal conductivity of ocean water is still a subject of active scientific research, there are several hypotheses based on what we currently understand. First is that the nanoplastic particles, they can disrupt the bond structures around the water molecules. This in turn can impact the thermal conductivity of water on a microscopic level. And second, the nanoparticles, they can form a thin film under surface water, which can impact the exchange between the ocean and the atmosphere. And finally, these nanoplastics, they can also interact with other particles in the water, forming aggregates and potentially affecting the heat transfer within the aquatic media. So these nanoplastics, they certainly affect the ocean's thermal conductivity, and we, as humanity, we haven't yet just realized how profound the impact might be.
All this pollution from oil, microplastics, and other chemicals is leading to even greater acidification of ocean water. You see, ocean acidification is not just a problem. It's also the reason microplastics break down into nanoplastics much faster. This only exacerbates the accumulation of heat in the ocean. Moreover, the use of hydrocarbons like methane and oil for fuel combustion and plastic production has significantly aggravated the ecological situation on our planet.
The greenhouse gases heat the atmosphere, which consequently heats the ocean surface. This leads to accumulation of excess heat both in the atmosphere and the ocean, and as a result, it increases the evaporation and the humidity in the atmosphere. So we find ourselves in a vicious cycle. That is, the worsening condition of the ocean, it impacts the atmosphere and vice versa. And climate disasters, they keep intensifying, so we must do something about that.
So in answering the question, what is heating the ocean? We have now considered only one option: changes in the properties of the ocean itself. And we have one more option left. What if more heat began to enter the ocean from somewhere else? Heat from the sun has not increased, and we have already accounted for the heat from anthropogenic heating of the atmosphere in our models. But is nanoplastic capable of increasing ocean heating at a rate equal to the energy generated by 7 atomic bombs, such as those dropped on Hiroshima, exploding every second for a year? We didn't use that much energy to produce all this plastic. So how could it be the sole cause of the warming? I definitely don't think so. After all, when you add noodles to soup, it doesn't heat up on its own. Let's look at our soup thermos from a completely different perspective. What if it is not just a thermos, but a pot that stands on a hot stove?
A team of U.S. researchers have discovered that the mid-ocean depths have been warming 15 times faster over the past 60 years than they did over the previous 10,000 years. Moreover, the rate of ocean warming is accelerating every year. Raising temperatures at such depths where sunlight doesn't penetrate requires an immense amount of energy. One of additional factors contributing to warming of the atmosphere, and consequently of the world's oceans, is the release of methane. Large reserves of methane in the form of gas hydrates, clathrates, are located on the seabed of northern seas. Influenced by geothermal heat, those structures begin to melt, releasing methane in its gaseous form. Such methane releases occur periodically and are referred to as methane plumes or megaflares. This is particularly dangerous since methane has a greenhouse effect 25 times greater than that of carbon dioxide. 1 ton of methane causes the same warming effect as 25 tons of carbon dioxide.
So in April of 2014, the NOAA satellites, they detected an abnormal methane spike in the atmosphere over the Arctic region. And according to the geological data, the areas with elevated methane concentrations, they coincided with the mid-Arctic fault lines. The earthquakes observed along these fault lines indicate the movement of magma and release of heat flow.
Methane emissions are like gas bubbles at the bottom of a soup pot. They rise because the bottom of the pot is being heated from below. But what about the water at the very bottom of our pot? If the heating is coming from below, then the water at the bottom should also be warming up, right? That's exactly what's happening. And there's already quite a few studies pointing to this.
two deep, abyssal Argentine basin sites, over 4,500 meters, exhibit significant warming trends of 0.02 degrees Celsius per decade over the period of 2009 to 2019. This kind of temperature change requires an immense amount of energy to heat such a large volume of cold water at the ocean floor.
Scientists have observed an unusual warming of the deep waters of the Weddell Sea, near the coast of West Antarctica. While the upper 700 meters of water show almost no warming, the temperature of deeper layers is continuously rising. There are several explanations for this anomaly, but none of the causes have been fully determined yet.
Look, our pot of soup is heating up throughout its entire height, including the bottom. The plastic soup is unevenly distributed throughout the water column, but it doesn't bring in any additional heat by itself. So how did the extra heat get to the bottom? That's an interesting question, isn't it? Right now, the assumption is that heat from the deep ocean is insignificant, so small that it can be ignored. But what if we're wrong? After all, we know so little about the ocean depths. Bathyscaphs and sensors rarely dive that deep. Our understanding of hydrothermal heat at the ocean floor is based on old calculations and measurements. Let's take a closer look in that direction. Is it possible that we're missing something down there at the bottom?
Never before has science been tasked with monitoring temperatures at the ocean floor. Ocean monitoring systems, such as ARGO, use 3,500 buoys, but that's insufficient to provide a complete picture, as they only descend to half the ocean's depth and collect data from just 0.03% of the ocean surface.
We have absolutely no idea what's really happening at the ocean floor. Imagine that only about 3 to 3.5% of the entire ocean floor has actually been explored by humanity. Throughout history, only 8 devices have been built for such research, and there's a reason for that. Firstly, building them and conducting expeditions are extremely costly. Secondly, diving to such great depths is far from a simple underwater stroll. There are numerous technical complexities. 98% of the ocean floor lies at a depth of around 6,000 meters. For these reasons, space exploration is currently advancing even more than the exploration of the ocean floor.
Do you know that there are some innovative hypotheses already being considered in the geologic community, saying that geological processes actually have a significant impact on the climate system, including ocean heating? There are over 10 million geological objects on the ocean floor, such as volcanoes, faults, and hydrothermal vents. Just imagine this power. So let's admit that they could be significant factors in warming the ocean from the bottom. How would we know that? After all, these geological forces remain largely hidden due to their remoteness and insufficient monitoring. However, a far more important question is, why would these sources now start generating many times more heat than before? Can it happen that a lot more heat is starting to rise from the interior? And what facts could point to this? Let's assume that for some reason, an enormous amount of additional heat has appeared in the Earth's mantle. What will this heat do? Naturally, it will melt the mantle. It will become something like molten cheese. Let's think about what could follow. Hotter, molten magma will start moving toward the surface because it becomes less dense, right? What would be the first areas where we'll observe additional heating from the rise of this hot magma? The areas with volcanic regions and a strong temperature contrast. Do you know such a place? I do. For example, Antarctica. Are you surprised?
West Antarctica is not just an icy desert. It is one of the largest volcanic regions on the planet. Hidden beneath its ice sheet are over 140 volcanoes, making this region both unique and mysterious. Recent aeromagnetic studies conducted by scientists from Germany and the British Antarctic Survey have produced a map of geothermal heat flow in this region. They discovered a zone beneath the Thwaites Glacier where a significant amount of geothermal heat is rising from Earth's interior. This heat flow is closely linked to areas where glaciers are melting the fastest, highlighting complex interactions between volcanic activity and climate change in Antarctica. Beneath the icy surface of West Antarctica lies the giant Marie Byrd mantle plume, spanning nearly 1 million square kilometers. Volcanic activity in this region is driven by a hotspot, an area where a mantle plume, a stream of molten magma, rises from the depths of the mantle and reaches the Earth's crust. NASA research indicates that heat from this mantle plume warms the rock and ice layers above it with an intensity comparable to the heating of soil by the Yellowstone supervolcano. In areas near faults, the heat flow reaches 180 milliwatts per square meter, which exceeds the thermal activity of neighboring rock formations 3 times. These findings highlight the significant impact of subterranean volcanism on Antarctica's ice sheet.
So according to independent studies conducted by researchers from Japan, Russia, and Germany, underneath the central part of Greenland, similar to Antarctica, there is a mantle plume that may be responsible for accelerated melting of glaciers in the recent decades. And this is truly remarkable that the rivers and lakes exist not only on the surface of Greenland ice sheets, but also beneath the glacier, which is 1.5 kilometers thick. And to this date, about 60 subglacial lakes have been identified, and they were formed mainly because of geothermal heat and meltwater flowing through the cracks. The scientists have come to understand that the glaciers in Greenland, they're melting both from above and from below. And the fact that they melt from the heat from below that just completely changes our understanding of the impact of geothermal heat.
By means of gravitational studies, American scientists led by Professor Ralph von Fries from Ohio State University discovered that the greatest ice melting occurs in the northern part of Greenland, where the Earth's crust is the thinnest. An increased geothermal heat flow is observed there due to the presence of a mantle plume. Researchers from the Schmidt Institute of Physics of the Earth came to a similar conclusion. They found that magma flows rise from the core mantle boundary and approach the Earth's surface directly beneath the central part of the island. This may be an additional reason for Greenland's ice melting. Scientists calculated that the heat flow from this mantle plume is strong enough to melt the ice. Many other researchers have obtained similar results.
You see, over the last 30 years, glaciers in Antarctica and Greenland have started melting at an extraordinary rate. Scientists have already calculated that the ice in Greenland is now melting faster than at any time in the past 12,000 years. Isn't that strange? In other words, simultaneously with the anomalously heated ocean, we also observe anomalously melting glaciers. Moreover, they melt from the bottom up due to the increased geothermal heat flow. The glaciers are like ice cream placed on a stove, and now that stove is being heated. Now think about this. If there's more heat in the Earth's interior that is melting magma and turning it into liquid, where else can we observe its effects? Just like heated honey, liquid magma should start oozing out of volcanic vents. And is the current volcanic activity in balance? That's a rhetorical question.
The current atypical magmatic activity of our planet's interior raises concerns. Volcanologists record anomalies in various volcanic regions. Lava ejected by volcanoes has an atypical composition which is characteristic to magma in deep layers of the mantle. Also, in recent years, an acceleration of magma ascent from the depths of the Earth's crust has been observed in regions such as Iceland, Italy, the island of Mayotte, and the Canary Islands. This indicates an increase in volcanic activity on a global scale. Volcanologists are concerned about the sharp increase in the rate at which magma is rising. Processes that previously took hundreds or thousands of years today occur in just half a year. Thus, in the Bransfield Strait in 2021, the rise of magma from a depth of 10 kilometers was accompanied by 85,000 earthquakes. The crust in this area is 15 kilometers thick, and 10 kilometers have already been burned by active magma. The rapid rise of magma indicates the emergence of dangerous processes within the Earth. Activation of volcanoes points to the accumulation of a tremendous amount of energy in the planet's interior, seeking to break out.
You know, in recent decades, there have been serious changes deep inside the Earth, and that really concerns me. Magmatic activity is intensifying, and that's not just talk. We're seeing an increase in the number of earthquakes near volcanoes, and supervolcanoes like Campi Flegrei in Italy, Taupo in New Zealand, Yellowstone in the USA, and many others. This rise in seismic activity is a clear sign that magmatic processes are becoming more active. Magma chambers are filling up, which may indicate that those volcanoes are getting ready to erupt. Considering that all of them are supervolcanoes, it's truly alarming.
You know, the seismic activity is increasing not only near the volcanoes, but also on the ocean floor. So Professor Arthur Vitrito, he's an oceanographer from University of Maryland. He has observed that since 1995, the number of earthquakes on the ocean floor along the mid-ocean ridges, they've been rising. And here's what's interesting. So this increase correlates very well with the global temperature rise. And the correlation that he had found was 0.7, although the temperature, it lags the seismic activity by about 2 years or so. It appears that the seismic and volcanic activities along these ridges, they enhance hydrothermal emissions and contribute to the warming of the oceans, which consequently, it leads to the release of greenhouse gases and, of course, the warming of the atmosphere. And when you put all this together, it really seems that all these observations are interconnected.
Volcanic eruptions and earthquakes are often closely related. Think of the Pacific Ring of Fire. This is not only an area with active volcanic activity, but also the most active seismic zone. If there is a growing number of earthquakes along the boundaries of lithospheric plates on the ocean floor, it is logical that it should also grow on the opposite sides of the lithospheric plates, right? Do you know what's happening with seismic activity in the Pacific? It has doubled in the last 30 years. That's an impressive increase in seismic activity in the region, and it has nothing to do with sensors, as the number of major earthquakes is increasing, which is not in any way affected by an increase in the number or sensitivity of sensors. Isn't that surprising?
In the modern era, we are witnessing an unprecedented exponential increase in the frequency of significant earthquakes compared to historical data. Analysis of USGS data shows that prior to the 2000s, there were only 1 to 2 major earthquakes of magnitude 6.0 and above per year. Today, their number has increased eightfold. Moreover, earthquakes are now occurring in regions that were not previously known for seismic activity. Seismic maps from recent decades clearly demonstrate the geographical expansion of seismic events, which now extend beyond the boundaries of tectonic plates and are occurring within stable platforms. Some argue that the increase in earthquake numbers is due to the expansion of seismic sensor networks rather than a rise in the number of events themselves. It is true that over time, the number and sensitivity of seismic sensors have improved, allowing for the detection of smaller magnitude earthquakes in greater detail. However, by the 1970s, enough seismic sensors had already been installed to record all earthquakes with a magnitude of 4.0 and above. Therefore, the observed increase in earthquakes since 1995 is not due to technological advancements, but reflects actual changes. Over the past 25 years, seismic activity has significantly increased and continues to rise. The rise in the number of earthquakes with magnitudes of 5.0 and above is also confirmed by data from the International Seismological Center.
So, we see a set of factors indicating that something is happening in the planet's interior. Something concerning, which we now associate with an increase in the interior heat. The Earth's crust is responding to this increase in heat in various ways. It appears to be heating up more than usual. Volcanoes are erupting lava of a typical liquefied and deep layer composition, and the number and magnitude of earthquakes are rising. To put it simply, the Earth's crust is cracking at the seams under pressure that comes from the interior, and this is probably caused by molten magma. Can we find out what's happening to the mantle now? If there are any changes occurring there? It turns out we can. And that's where data on deep focus earthquakes help us.
Deep focus earthquakes are unique seismic phenomena occurring at depths greater than 300 kilometers, and sometimes reaching as deep as 750 kilometers beneath the Earth's surface. These events take place under extreme pressures and temperatures, where, according to predictions, the mantle material is expected to deform plastically rather than be brittle, which makes their occurrence puzzling. However, they are regularly recorded and remain the subject of active scientific investigation. Since 1995, the frequency of deep focus earthquakes has increased sharply, coinciding with other geodynamic anomalies. The rise in the frequency of such earthquakes in recent decades is associated with heightened magmatic activity deep within the Earth's interior.
There is a hypothesis that the deep focus earthquakes, they represent the powerful underground explosions comparable to the detonation of many atomic bombs in the Earth's mantle. The exponential growth in number and strength of such earthquakes indicates intense magmatic activity in the planet, and also raises concern that such earthquake could serve as triggers for more destructive earthquakes on the surface.
This is undoubtedly shocking because, apparently, an enormous amount of additional heat has indeed emerged in the planet's interior that is likely intensively melting the mantle, which is reflected in the increase in deep focus earthquakes. But where is this heat coming from? And at what point did it start coming in? That's a good question, isn't it? Perhaps we need to look deeper to find the answer. After all, the hottest part of our planet is the Earth's inner core.
So science has come to understand that the temperature between the Earth's inner core and the liquid outer core, the temperature is approximately the same as the surface of the sun. And we're talking about 6,000 degrees Celsius. 6,000. Can you imagine that? The same temperature as the sun, but in the core of our planet. And how could the core remain so hot for 4.5 billion years of its existence?
Is everything all right with the planet's core? Can we be sure that no dramatic changes have begun there? As it turns out, in 1995, some quite strange processes started happening in the planet's core that cannot be ignored.
In 1995, scientific laboratories around the world recorded alarming planetary anomalies for the first time. One of the most noticeable changes was the abrupt acceleration of the movement of the North Magnetic Pole. Previously, it had been drifting at a rate of 10 kilometers per year, but since 1995, its speed increased to 55 kilometers per year. Additionally, it changed its direction towards Siberia, advancing over 1,000 kilometers.
This abrupt shift of the North Magnetic Pole, it's a truly unique event that has not been observed for the past 10,000 years. Can you believe that?
According to the current theory, Earth's magnetic field is generated by the flows of molten iron moving around the planet's solid core. In 2013, a group of scientists from the University of Leeds made a significant discovery. Changes in Earth's magnetic field are linked to the acceleration of the flow of liquid iron in its outer core. This acceleration appears to have begun in 1995.
Meanwhile, changes in the Earth's magnetic field are not the only events that occurred in 1995. Numerous geodynamic parameters changed that year.
In 1995, there was also a disruption in Earth's rotation. The direction of the planet's rotational axis shifted, and its rotational speed increased by 17 times. Scientific studies point to October 1995 as the breakpoint of polar drift. At the same time, in 1995, there was a sharp leap-like increase in Earth's rotational acceleration. Data from the Paris Observatory shows that during these years, the length of a day began to shorten by a few milliseconds, indicating that Earth started rotating faster than usual.
In 1995, three major changes in Earth's geophysics occurred at once. Firstly, the drift of the North Magnetic Pole accelerated dramatically. Secondly, the Earth's axis of rotation shifted its direction. And finally, the planet began to rotate faster. All these processes are directly related to the Earth's core. The magnetic field is generated by the geodynamo, and the planet's rotational speed and axis rotation direction depend on the inner core. This suggests that since 1995, serious anomalous changes have been happening in the Earth's core, which require enormous energy. The core appears to be heating up, which causes its disbalance. Meanwhile, it is the engine and the heart of our planet.
Moreover, Earth's magnetic field is weakening. The South Atlantic magnetic anomaly is expanding, and the magnetic field there has already weakened by 30%. Satellites even power down some of their equipment when passing over this zone to avoid damage from cosmic radiation. Our magnetic shield is like a sieve now. In recent years, we've begun to notice alarming consequences of the weakening magnetic field. Red auroras are appearing in places where they never existed before. This phenomenon has been especially active in recent years, which is why geomagnetic storms have become so dangerous, and that really worries me.
The changes that began in 1995 didn't stop. They continued to increase. Therefore, in 1997 to 1998, the Earth's core experienced phenomena that had never occurred in recorded history before. Many scientists wrote about those phenomena, and they are tremendous.
In 1997 to 1998, scientists, using satellite data from the Earth's center of mass, recorded a unique phenomenon, a sudden shift of Earth's inner core. As a result, the core moved northward along a line from West Antarctica to western Siberia, towards the Taymyr Peninsula in Russia. At the same time, 4 independent scientific groups detected anomalous changes in various geophysical parameters, confirming this event. According to scientists such as Doctor of Physics and Mathematics Yuri Barkin, Doctor of Engineering Gennady Smolkov, Doctor of Geography Mikhail Arishanov, RAS academician Victor Kane, and many others, the core shift in 1998 caused changes in all of Earth's layers.
The significant displacement of the Earth's core, which is comparable in size to the Moon, really makes us ponder. Where is the energy coming from that causes such anomalies in the Earth's internal structure? It seems the core is experiencing some sort of imbalance and heating up. At the same time, we observe an increase in geothermal flux, intensified volcanic and tectonic activity, and anomalous polar auroras. And the most alarming thing of all is that we witness tremendous heating of the ocean, leading to an increase in climate disasters, floods, and hurricanes. Doesn't it look strange to you that all of this is happening at the same time? The question of the source of this colossal energy, which surpasses humanity's energy potential by millions of times and is heating up the core and the mantle, still remains open. We have certain ideas regarding astronomical cyclicity, but that's not the topic of our conversation today. It's important to understand that the model we have presented explains many of the planetary anomalies which we observed over recent decades. But we mustn't forget about the anthropogenic factor either. Recall the plastic soup filling the ocean basins. The polluted ocean cannot dissipate heat effectively, which is why the escalation of disasters is happening faster than predicted. It's terrifying to think how this might end.
So throughout our geological history, many catastrophic events have occurred which are characterized by abrupt and extreme shifts in global climate conditions. For example, volcanic winters, such as the one that triggered by the eruption of Toba volcano 74,000 years ago. And this event has reduced the human population to less than 10,000 people. Similarly, a sudden weakening of the magnetic field that coincided with the extinction of Neanderthals, and this happened about 36,000 years ago. And about 12,000 years ago, there was abrupt warming events which contributed to the extinction of mammoth. And now, will we, as humanity, will we have the wisdom and courage to avoid their fate and take action in time?
Some researchers believe that if the situation with the ocean doesn't change, natural disasters will obliterate all life on Earth. We have only a few years left before reaching the point of no return. So right now, as our planet's interior is heating up, we desperately need a functioning cooling system. But it is clogged with plastic soup. Imagine a nuclear reactor where power has been increased, more nuclear fuel added, but filters in the cooling system are clogged. Now, instead of cold water, the reactor is being cooled by a viscous sludge. Can you imagine what will happen to that reactor? Are there any chances to clear the filters of our planetary thermostat from micro and nanoplastics? The answer is yes. The key to solving this problem is restoring the cooling function of the ocean. Imagine if we started extracting moisture from the atmosphere, stimulating the ocean to evaporate even more. If we redirect all excess moisture for our needs, it will not cause more floods. Yet while the ocean evaporates, nanoplastics will also be released, and we'll be able to recycle them. This technology can essentially work like an air purifier on a planetary scale. It sounds ambitious, but it's true. The technology of atmospheric water generators will ensure extraction water from the atmosphere.
The way the machine is designed, the air that comes into the machine is filtered to start with. The moisture is condensed out of the moisture that's in the air. So the only thing that the machine is seeking is the H2O molecule, which is smaller than a piece of microplastic. The filtration strips everything off. Then, yet again, when it goes into the tank, before it comes out to the consumer or the people who use the water, it goes through another large section of carbon filtration laced with silver, so that it not only doesn't impede the growth of bacteria, but it strips off anything else that's in the water. It's an incredible process.
Atmospheric generators filter water and remove all impurities. If used on a large scale, they could act as a kind of artificial filter in the planet's water cycle. After several years of active use, the ocean and atmosphere would be significantly cleansed. The ocean would begin to transfer heat back to the atmosphere, from where it would escape into space. This would help mitigate the destructive consequences of disasters and cleanse our ocean and atmosphere.
It will have some environmental impact, a positive impact, because when we process ambient air, we filter it from dirty stuff as well. For example, smog and flue gases and all, and sand and everything that flies around in the air, really. And so that's one impact we have. When it comes to the water content in ambient air or in the atmosphere, as I mentioned previously, there's absolutely no way of extracting or disturbing the natural balance of the atmosphere, because it's simply too big and it's too powerful.
I really love this technology. It's an environmentally friendly solution to the problem of drinking water scarcity. It can be used both at home and in large enterprises, as well as in agriculture or even out in the field. This is truly an innovative solution for accessing clean drinking water, especially in areas with limited resources.
The technology there can create water anywhere, because the technology is used in such a way. Heating and cooling creates condensation. So whether it's in Devil's Valley in Nevada or in the Sahara Desert, we can still make water there. So we can make water anywhere on the planet.
We agree. It is a big thing when you are using atmospheric water generator in each home. Then you will not ever use these plastic bottles. So by using the atmospheric water generator, we are seeing that we will solve the water issue. We will reduce the footprint that is from the plastic industry. We will reduce the carbon footprint from the transportation, and we will help the environment to return to the natural cycle.
Moreover, when intensive evaporation occurs, the ocean cools down, similar to how evaporation of sweat on our skin cools a person in the summers. So likewise, if the atmospheric water generators are used on a large scale, worldwide, then the atmosphere, it will become less humid and cooler. So consequently, the hurricanes and storms will weaken, and the frequencies of extreme precipitation that we're seeing today, they will also decrease. And that could save millions of lives and prevent multi-billion dollars in losses. And that's exactly what we need right now.
I designed and developed the technology to a place where I can build an atmospheric water generator that could produce over 100,000 liters a day. 200,000 liters a day. It's not difficult anymore. You just have to think about it long enough.
Even if 8 billion people take 100 liters of water from the moisture, there will be enough evaporation to refill that. And this is what we should be looking to doing. And it is clean, right? And it is available everywhere to everyone. And so I think suddenly the world has woken up to this alternate source.
This is a remarkable technology, but it does have limitations. Specifically, the energy consumption involved. Manufacturers are currently trying to figure out how to make their systems more efficient and cost-effective. They install solar panels, which works for small generators. But at an industrial scale, especially in the context of global climate change, that's not always effective and can be vulnerable.
We need a powerful, eco-friendly, and most importantly, affordable energy source. To start the process of cleaning the ocean on a global scale, we need to get all water solely from the atmosphere. Currently, even manufacturers of water generators may find this goal too ambitious. But once they have an alternative energy source, using atmospheric generators worldwide will only be a matter of time. That's not a panacea, but it's a crucial step in the right direction. It's the only way we can gain the time needed to halt disasters and preserve the Earth for future generations. It is truly a global project and one of the key means in saving our planet and the entire humankind.
The atmospheric water generators are truly promising technology, but they must be part of a comprehensive approach. The first step is to fully transition to atmospheric water generators and stop extracting water from the surface and underground sources. These devices can produce as much water as needed for both for drinking and for industrial purposes. And the second step is to reconstruct the current sewage systems. For example, the water, they should not be discharged into open water bodies, but pass through the soil layers and get purified before entering any water bodies. And third is to implement the fuel-free energy generators. They're essential in providing the adequate and accessible energy to these atmospheric water generators, which are quite energy intensive.
The moisture for water generators should come from natural sources, so we must eliminate open reservoirs. Putting fuel-free generators into operation will help reduce our dependence on hydroelectric power and allow us to open dams. Restoring rivers to their natural courses and returning to natural flows will help eliminate water stagnation and allow ecosystems to come back to life.
Imagine that according to calculations, extracting water from the atmosphere can solve 70% of the planet's worsening climate situation, and wastewater purification will make up for another 30%. This approach allows us to simultaneously achieve several goals set by the UN General Assembly for Sustainable Development. We can combat climate change, provide clean water to those in need, and restore ecosystems at the same time. This is just amazing.
Although the situation is serious, we have reasons to be optimistic. With the right approach and international cooperation, we can overcome these challenges. These are the key steps to saving the planet. If we implement them, we will start seeing results within 2 or 3 years. However, it's important to understand that climate change keeps accelerating, and this process will not stop immediately. In the first year, the situation may fluctuate slightly, but after about 8 to 14 months, everything should stabilize. And in 5 to 8 years, we will see how water will clean up and the ocean will resume performing its function of cooling the planet. Floods, droughts, anomalous winds, and temperature fluctuations will cease. The climate will become much milder and more predictable. Ultimately, with the introduction of atmospheric water generators, we will gain the time that we now need so desperately to address the causes of the planet's heating.
The proposed scientific and practical approaches could serve as the foundation for a new technological revolution. They are aimed at ensuring sustainable water supply and balanced use of water resources. Most importantly, these measures have the potential to reduce the negative impact on the planet's climate system. They hold significant potential for seriously improving the environment situation, making Earth more resilient to climate challenges.
International cooperation will play a crucial role. To solve this global problem, we need to unite the efforts of scientists, policymakers, businesses, and the public. By combining our efforts and resources, we will be able to develop and implement comprehensive solutions. Instead of working separately and trying to undermine one another, we must act together because this is a global problem. One of our main problems we have today is that we tend to act more for profit than for the benefit of humanity. We must do everything we can to change this mindset for the sake of the well-being of all humankind.
If we can establish conditions for open scientific collaborations worldwide, the scientists, they will be able to build upon the current knowledge and understanding and to mitigate the increase in natural disasters. The future of our planet depends on the decisions that we make today. We must act together to clean the oceans from the micro and nanoplastics and mitigate the effects of climate change.
We can really change the situation. We already have the technology. All we need is the will to act and the global cooperation. Only by joining efforts can we stop pollution of the ocean and change the climate situation on Earth.
The future is in our hands. Let's protect the ocean together and create a sustainable future for our children.